So I will present comparison of potential life expectancy gains for different dietary changes, and will exemplify this from a number of countries, and then presenting some longevity optimized diets, but also some other vegetarian and vegan diets, and also some feasible dietary changes. And as mentioned, this goes out from the Food for a Healthy Life study, and I will explain more about that. As you probably all are very much aware, globally dietary related risk factors, they together contribute to about 250 million disability adjusted life years per year and 11 million deaths, and which is something like 22% of the deaths of the overall deaths, and mainly related to cardiovascular diseases, diabetes type 2, and cancers, which are the dominating causes. And as you also are probably well aware, the field of nutrition is huge, and just in the period of 2017 to 2022, about 250,000 scientific articles were published and indexed within PubMed. And navigating within this field can be overwhelming to clinicians, policymakers, and even to researchers. So part of our aim going into this was to try to build this better together. And before this, the Global Burden of Disease study has provided some summary measures, and they have also updated some of these and are about to update them a little bit further recently. Oh, sorry. Here. And also the Eat Lancet, they have provided some estimates for healthy planetary diets, but few tools are available to say more about the details of different type of changes and what people can expect in terms of health gains and longevity gains. As mentioned, that was our background going into this field, and to build these models within the Food for Healthy Life framework, and initially established by, in addition to myself, Jan Magnus Økland, Professor Øystein Haaland, and Professor Kjell Arne Johansson, mathematicians, statisticians, and medical doctors, but also a larger group of people with nutrition background and different type of health backgrounds, Carlos Cheris Morales, Catherine Livingston, Professor Antonello Lorenzini, and Professor John Mathers. So we are an expanding group. Some of these are the first results from this was published in the PLOS Medicine in 2022, and then more validation-based paper where we used data from UK Biobank was published last year in the Nature Food, and then recently, during the last months, a publication was published in the American Journal of Clinical Nutrition, and then we also have some of the findings I will present today are also under review and will likely be published during the next few months. And some of these have got overwhelming media attention. For example, the first of these papers got more than 700 news stories and more than 400 newspapers and TV channels, so they were quite widespread. Let me first show a little bit of the methods that we have employed in these models. So first, we use background mortality and morbidity from the global burden of disease study. I will explain more details to all of these too. We put on top of that food group-based associations between food intake and all-cause mortality from meta-analysis. We employ methods to account for effect delay and the time association between prevention of disease risks, cardiovascular disease, etc., and food changes, and we use some model, some conservative model assumptions to account for potential residual confounding, and we use some Monte Carlo simulations to measure likely uncertainty. I will explain more to all of this. First, much of the background data that we use comes from meta-analysis on associations between intake of different food groups, of fruits, vegetables, nuts, dairy, processed meat, red unprocessed meats, white meat, legumes, etc., and how they are associated with all-cause mortality. And just to exemplify this is from fruits and vegetables, and for that there were more than 50,000 relevant sources which were screened, and then more than 100 large cohorts which together included more than 2 million participants, and more or less, or most of these were adjusted for both smoking, physical activity, alcohol intake, and other typical risk factors for premature mortality. And similarly, there were meta-analysis for whole grain, for and fruits and vegetables, as mentioned, for different other food groups. I'll come back to that. On red processed and white meat and associations to all-cause mortality, and we also used data on polyunsaturated fatty acids to say more about added oils, and then on nut consumption. And just to briefly show a little bit of what went into the models. For example, for whole grains, there were data on nonlinear dose response associations between all-cause or the intake of whole grain and all-cause mortality, and indicating lower mortality risk with higher intake of whole grain. Similarly for fruits and vegetables, and also similarly for nuts, but for nuts plateauing with an intake probably in the range of 30 grams. And then we also had similar data for all the food groups that I will soon present. Then the question is, how can these be built together? And I'll say more about that. And the values, the non-linear dose response values from these were extracted, and then we projected these further, slightly outside these ranges, and then but also providing not providing data far outside the ranges, and then this was built on top of background mortality from the global burden of disease study. And as you are probably all aware, the background mortality and the background longevity in different parts countries varies, and the nutritional risk profile is then put on top of the background mortality. So we used the global burden of disease study and data from there, and we used pre-COVID data from 2019 in our models, and we extracted from each countries with age-specific groups. So estimating mortality for people in the range 20 to 25, or and 18 to 20, 25 to 30, etc. And so and then all the way up to the age of 100. And then as we and other research indicate that if people do some short-term dietary changes, gains are not likely to be the same as if they continue doing changes over a long time. So to account for these time differences, we needed to make assumptions on how time affected. So we assumed, based on studies, for example, some mechanistic studies, and including also imaging and from intervention, nutritional interventions, and changes in atherosclerosis and atheromatosis and cardiovascular risk profile. We assume that if people sustained changes for a period of up to 20 years, they could achieve the kind of maximum, and then it will be kept at that level, the risk reduction from then on, but and then that we used an S-shaped curve up to that point. So we had kind of 20-year effect increase with sustained changes, implying that short-term changes are likely not to be as impactful as longer changes. We also said and presented uncertainty estimates. And the background data for each food group came with confidence intervals. However, when we built this together, we used Monte Carlo simulation. So we kind of drew values uniformly within the ranges of each of the food groups, and then and then we ran 200 such models, which kind of drew randomly within the ranges, and that was the uncertainty level we presented in our models. The studies, the background studies, showing associations between intake of different food groups and all-cause mortality. They were adjusted for smoking, for physical activity levels, for alcohol, and other known substantial risk factors. However, there could still be residual confounding within these data, and to provide more, and also some between, even though these several of these were adjusted for other food groups, there could also be some overlap in the associations presented for each of the food groups. So, but some data which has modeled the degree of overlap indicate that this is not substantially, probably in the range of 13–14%. But to be conservative, we then used a 25% effect reduction, with, in other words, making our models more conservative than the data directly implied. So we assumed a little bit of unmeasured residual confounding. We also used data which have later been updated to, for example, from Anhanes in the US, from Nordkost in Norway, and data from France, Germany, UK, China, Iran, and different Nordic countries, etc., to estimate how did typical dietary patterns look in each of these countries. And so how much vegetables, how much fruits, how much red, processed, white meat, etc., are typically eaten in each of these settings. And these went into the initial eating patterns, and then we modeled what could people expect when changing from typical eating patterns to, for example, longevity optimized, which is defined where, based on the dose response, nonlinear dose response data for each of the food groups, where the lowest mortality risk could be expected, and then we also provided a so-called feasible changes, which is somewhere midway between the longevity optimized and typical dietary patterns in several of these countries. And then we also provided an estimate of those, accounting for both ethical and climate-related aspects. For example, optimized vegan or vegetarian dietary pattern, where not including meats, and also one not including dairy and eggs. So these, and then we also measured both the energy level intake in each of these, and we also estimated the number of uncategorized energy when we, and that also accounted to uncertainty. So the higher the uncategorized energy, the higher the uncertainty in each of these models. We also made estimates on the evidence quality, and several of these meta-analysis on the food groups, they used NutriGrade to grade the quality evidence, and then we weighted that. So we weighted the contribution from each of the food groups, and then we presented overall evidence for our models and for the likely gains, and estimated that overall gains were likely to be of moderate evidence. So this is presented in a web application, so it can be, if going to the web address foodforhealthylife.org, one can play around with this. One can check different type of dietary inputs and see how it plays out. So this utilizes an R package called R-Shiny, and one can then compare the input comparison diets, for example, diet before a change, and then diet after a change on the right-hand side, and then and it is then estimated the likely life expectancy gains or losses depending on the changes, which is also, and the contribution from each of the food groups, from whole grains, sugars, sweetened beverages, nuts, legumes, etc. And this also with inputs on both the country, the exact age, and also in our last models we also include also weight, height, and physical activity level. Physical activity level not then contributing to the as health gain or mortality gain, but to the energy intake requirements. So so just in short, some of the results we show that was that for many of the populations, or I can go to some of the later results first. Our first results indicated that legumes, whole grains, and nuts, or increases in these, and reduction in red and processed meat, as well as sugar sweetened beverages, are the changes that most populations, especially in the US, in China, and European countries, is what would achieve the most health gains, the most increases in longevity, and part of the reason that fruits and vegetables is lower on this list is that the intake level of fruits and vegetables are closer to the optimal than what they are for example, legumes and whole grains in many settings. We also show that feasible dietary changes can provide quite substantial gains also. So with optimal dietary changes in many settings, showing likely gains of in the range of 7 to 10 years. Feasible dietary changes typically range around 5 to 7 years of health gains for people in around the age of 40. We also tried to validate or to use make a similar model based on very different data from the UK Biobank, and the data structure was quite different. So we used, instead of continuous background data, we used quintile-based background data. Nevertheless, the overall results were quite similar, showing more or less the same, that whole grains and nuts and reduction in red and processed meat, as well as sugar sweetened beverages, were the changes that were likely to have the strongest impact in UK. As mentioned in the recent model, we also account for height, weight, and physical activity level. And just to show some of the likely gains that we estimate. So the yellow parts of these graphs that you see, these are the differences between typically dietary patterns in each of these countries: China, France, Germany, UK, Norway, Iran, and the US, and what they could achieve if they implement what we rate as feasible dietary changes. And they generally overlap quite well with dietary recommendations in many of the countries, with a conservative interpretation. So kind of just achieving it, not overachieving it. So but going from there to optimized levels, have a further likely life expectancy gain, and so the differences between what typically is and the typical life expectancy and the life expectancy people could expect by optimizing their diets is in the range of 7 to 9 years in these settings. Your adults like expected gains. And we also estimated what could be, how much of this contribution is from each of the food groups. And as you see, whole grains contributes to about a fifth of this, and then reduction in processed meats and in red meat accounts also for a substantial part of this, and also increase in the intake of legumes is also substantial and almost a fifth of the gain, and then increase in the intake of nuts accounts for something like a sixth of the gain. Similarly, we also modeled in relation to the, as many of you might know, the Nordic and Baltic countries revised their nutritional recommendations recently, which were published in June last year. And then, and following that, we modeled how much gains could be expected from either conservative or from a more health optimized interpretation of these recommendations, and show that that the gains are substantial in all of these countries, and typically in the range of 5 to 8 years for 40-year-old adults. We are now working on distributing or providing even more data on how the disease-specific risks are likely to change with cardiovascular disease, diabetes type 2, probably also all cause or cancers independent of type, and then obesity. And we will also estimate the greenhouse gas emissions, the water use, land use, and other sustainability metrics for each of these dietary patterns. So just in summary, sustained dietary changes is expected to give substantial health gains for people throughout life, and it could be as much as 10 years for people in their early adulthood, changing from very unhealthy diets to very healthy diets. And the largest gains is expected from eating more legumes, more whole grains, nuts, and less red and processed meats, and less sugar-sweetened beverages. And even though it changes, the earlier people change to healthy diets, the better. There is still substantial gains also for people changing, for example, in their 60s. So that was a short summary of our current results. Thank you.